JUnit as a habit, not an afterthought. Appendix B, JUnit configuration properties. JUnit configuration properties. Here are some of JUnit-platform.properties files properties that we covered in our course, GRG-001. The list of possible values for those properties are after the equals sign in the square brackets separated by pipe. The default value is bolded. There are in fact 3 different ways to specify configuration properties. So let's review each one of them in detail on the next slide. These are the 3 different ways in which JUnit configuration properties can be specified in order of decreasing importance. Way 1. By using your preferred way to launch the unit tests. So if you are using the launcher API, you can do it by using the configuration parameter method or the configuration parameters method of the launcher discovery request builder class. If you are using the console launcher, you can do it by using the --config command line option. If you are using Gradle, you can do so by using the system property or system properties DSL. And if you are using Maven Surefire plugin, you can do it by using the configuration parameters property within its XML configuration. Way number 2 is by using Java Virtual Machine's command line properties, which start with -d, such as -d JUnit.someProperty etc. equals something. And the third and final way is by putting the configuration properties into the JUnit-platform.properties file and by including that file within your project's class path. The following are the precedence order of how these configuration properties are taken up into the JUnit runtime if they repeat themselves, for example, or override themselves. Repeated configuration properties from number 1 override those from number 2 and or number 3. Repeated configuration properties from number 2 override those from number 3. This inheritance structure is clear and unambiguous. If you write custom functionality to extend the JUnit framework, you can create your own custom configuration properties. Let us now look at some built-in configuration properties we reviewed during the course of our study in the JUnit 5 framework. Properties related to name generation or description generation. JUnit.jupyter.displayName.generator.default equals fully qualified class name of a class implementing the displayNameGenerator interface. And so whenever I give you a property, I'm going to make a 30-second pause per property for you to write it down if you wish. I suggest you do it. Will just add to your knowledge, and that's an advanced topic, so it's good to know. So let's start by doing this first one. JUnit.jupyter.displayName.generator.default equals FQCN of a class implementing the displayNameGenerator interface. And for this one, I'm going to give you 45 seconds to write it out. As an example, you could have JUnit.jupyter.displayName.generator.default equals org.JUnit.jupyter.api.displayNameGenerator $replace underscores, which is a built-in inner class that replaces underscores in your method name with spaces. The next one is belongs to a class of test class lifecycle properties. JUnit.Jupyter.test instance.lifecycle.default equals square brackets per underscore method pipe per underscore class brackets closing. And let me give you 45 seconds to write it out. So an example could be JUnit.Jupyter.test instance.lifecycle.default equals per class. It's actually default is per method, but if you want one per all unit methods in a class, you would do per class. The next one is belongs to the class of timeout configuration properties, and there are lots of them. So let's get started. The first one is JUnit.Jupyter.execution.timeout.default equals a number of, which is either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And that's the default timeout value for all testable and lifecycle methods. So for all unit tests and lifecycle methods. I'm going to give you 45 seconds to write it out. The next one is JUnit.Jupyter.execution.timeout.testable.method.default equals, and in square brackets, a number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And that's the default timeout for all testable methods. That is, all unit test methods annotated, which are annotated, as you know, with .test. So I'm going to give you 45 seconds to write it out. Alright, let us go to the next slide. The next one is JUnit.Jupyter.execution.timeout.test.method.default, and which is a number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And that's the default timeout for @test methods. I apologize for the previous one where it is testable methods. It is all methods which either are unit tests or produce unit tests or are the templates for unit tests. So it would be for all @test methods, @test template methods, and @test factory methods. So, and now we get to finer granularity, and right now we're on the default timeout for @test methods. and I'm going to give you 45 seconds to write it out. That's again JUnit.Jupyter.execution.timeout.test.methods.default equals number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'll be back in 45 seconds. Alright, the next one deals with the default timeout for add test template methods. And the configuration property is JUnit.Jupyter.execution.timeout.test.template.method.default equals the number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'm going to give you 45 seconds to write it out. The next one deals with the default timeout for add test factory methods, and it is JUnit.Jupyter.execution.timeout.testFactory.method.default equals the number of either nanoseconds or microseconds or milliseconds or seconds or minutes or hours or days. And I'm going to give you 45 seconds to write it out. Alright, the next one deals with the default timeout for add before all lifecycle methods. And it is JUnit.Jupyter.execution.timeout.beforeall.method.default equals the number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'm going to be back in 45 seconds to go to the next slide. Alright, let us go to the next slide where we will see more timeouts for lifecycle methods. The default timeout for add before each methods is as follows. JUnit.Jupyter.execution.timeout.beforeeach.method.default equals a number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'm going to give you 45 seconds to write it out. Alright, the next timeout configuration properties is for the default timeout for add after each methods, and it is JUnit.Jupyter.execution.timeout.after each .method.default equals a number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'm going to give you 45 seconds to write it out. The next one is going to be the default timeout for it after all methods, and it is JUnit.Jupyter.execution.timeout.after all.method.default equals a number of either nanoseconds, microseconds, milliseconds, seconds, minutes, hours, or days. And I'm going to give you 45 seconds to write it out. Alright, the next one is a configuration property that overrides all of those we just encountered, and it disables timeouts globally. And it is JUnit.Jupyter.execution.timeout.mode equals either enabled, which is default, or disabled on debug. And I'm going to give you 30 seconds to write it out. Alright, let us go to the next slide. The next one deals with parallel execution, which is an experimental API, but it has some configuration properties nonetheless. So, how do you enable parallel execution of unit tests? The first configuration property is JUnit.Jupyter.execution.parallel.enabled equals either true or false, which is the default. And I'm going to give you 30 seconds to write it out. So excuse me, the next configuration property is JUnit.Jupyter.execution.parallel.mode.default equals same underscore thread, which is the default, or concurrent. So this is the configuration property that controls the execution mode for unit tests. And if you recall, the add execution annotation overrides this value for individual test classes or individual test methods. It also specified parallel executions specifically for test methods per test class, if the next configuration property is set, which we will see on the next slide, or for all test methods in all test classes, if the next configuration property is not set. So I'm going to give you about 45 seconds to write it out, and then we'll go to next slide where we will delve into the nuances of what this configuration property controls and when. Alright, let us go to the next slide. So the next configuration property we are going to review deals with parallel execution for test classes. And it is JUnit.Jupyter.execution.parallel.mode.classes.default equals either same underscore thread, which is the default, or concurrent. So it does the same thing as the previous configuration property, but only specifically for test classes, not test methods. And for example, to have all test methods in all test classes run in parallel, both these configuration properties must be specified with concurrent value. And obviously there are several permutations which can be achieved by setting these two last properties to either same thread or concurrent for permutations, in fact, and they all achieve different parallel semantics. So for example, if we made this last classes variable be concurrent, but we make the previous variable be same thread, then what will happen is that if we have 10 test classes, the runtime will spawn roughly 10 threads and run all the unit tests of a particular test class in one thread. If we set this last variable to same thread, but the previous one to concurrent, what will happen is that, and if we have 10 test classes, they will execute sequentially, but when one of them is executed, the runtime will spawn a certain number of threads to process all of its unit tests contained within the test class in parallel, and etc. etc. There are exactly 4 permutations plus a 5th special case when we specify the previous configuration but not this one. And so as a note, if the JUnit.Jupyter.execution.parallel.mode.classes.default configuration parameter is not explicitly set, the value for JUnit.Jupyter.execution.parallel.mode.default will be used instead for all unit tests within all test classes. So for example, if we set it to concurrent, then all the unit tests within all the test classes will try to run in parallel if you don't set this variable which has the word classes in it. So there are actually 5 ways to configure parallelism regarding test classes and unit test methods with the JUnit parallel API. And let us go to the next next slide. There is also something that allows us to define the strategy for parallelism by using the following configuration property: JUnit.Jupyter.execution.parallel.config.strategy equals either dynamic, which is default, fixed, or custom. So if no configuration strategy is set, JUnit Jupyter uses the dynamic configuration strategy with a factor of 1. Consequently, the desired parallelism will be equal to the number of available processors or cores. For example, if we have a 2-processor system with 4 cores per processor with hyperthreading, which makes it like 8 logical cores per processor, we're going to have at maximum 16 threads processing our unit tests. So let me give you about 45 seconds for you to write out JUnit.Jupyter.execution.parallel.config.strategy equals dynamic, fixed, or custom. So, and I'm going to be back in 45 seconds. Alright, so when we use the dynamic configurations, parallelism configuration strategy, we must also use a factor, parallelism factor, which is specified by the JUnit.Jupyter.execution.parallel.config.dynamic.factor equals a positive integer and defaults to 1. This will cause our number of processors or cores to be multiplied by the above specified positive integer, and that will be the size of our thread pool, ideally. Because in the future slides we will see that the runtime doesn't guarantee actually the maximum number of threads, but that's our desired number of threads and a strong hint to the runtime. So I'm going to give you 45 seconds to write out JUnit.Jupyter.execution.parallel.config.dynamic.factor equals positive integer defaults to 1. And I'll be back in 45 seconds. Alright, so once again what this last configuration property does is it computes the desired parallelism or the size of the thread pool based on the number of available processors or cores multiplied by the above specified positive integer. Moreover, please note it says the desired parallelism because the JUnit runtime does not guarantee the maximum size of the thread pool. Let us go to the next slide. The next parallel execution configuration property deals with the fixed parallel configuration strategy. It is JUnit.Jupyter excuse me, .execution.parallel.config.fixed.parallelism equals a positive integer. So what it does, it uses the specified value for fixed parallelism, which is you basically specify the maximum number of threads in the thread pool. And once again, the JUnit runtime will take your desire under strong consideration, but it does not guarantee that it will fully adhere to the number you name. I'm going to give you 45 seconds to write out JUnit.Jupyter.execution.parallel.config.fixed.parallelism equals a positive integer. And I'll be back in 45 seconds. Alright, the next one deals with the custom configuration strategy. I mean parallelism configuration strategy. It allows you to specify the fully qualified class name of a custom parallel execution configuration strategy interface implementation. So this configuration property would be JUnit.Jupyter.execution.parallel.config.custom.class. Now I'm going to give you 1 full minute to write out two things. First is JUnit.Jupyter.execution.parallel.config.custom.class, and the second one is parallel execution configuration strategy. So I'll be back in 1 minute. Alright, well, this was slightly less than 1 minute, but I think you are probably already done, so let us go to the next slide. The next type of configuration properties deals with JUnit runtime extensions. And first, of course, you have to enable their auto detection, which is done via the JUnit.Jupyter.extension.autodetection.enabled property, which can either be set to true or false, which is the default. Now I'm going to give you 45 seconds to write this property out. Alright, so when auto detection is enabled, extension discovered via the service loader mechanism will be added to the extension registry after JUnit Jupyter's own global extensions, which are built in. Specifically, a custom extension can be registered by supplying its fully qualified class name in a file named org.junit.jupyter.api.extension capitalized within the /meta-inf/services folder in its enclosing jar file. So let us go to the next slide. Alright, so the next set of configuration conditions deal with execution conditions. And the first one of those is JUnit.jupyter.conditions.deactivate either star or regular expression with fully qualified class names. And I'm going to give you 30 seconds to write it out. Alright, if the JUnit.jupyter.conditions.deactivate pattern consists solely of an asterisk, all conditions will be deactivated. Otherwise, the pattern will be used to match against the fully qualified class name of each registered condition. Any dot in the pattern will match against a dot or a $sign in the fully qualified class name, which makes sense because it is a separator between either a top-level class or an inner class. Any asterisk will match against one or more characters in the fully qualified class name. All other characters in the pattern will be matched one-to-one against the fully qualified class name. For example, to deactivate the @disabled annotation, use JUnit.jupyter.conditions.deactivate equals org.junit.star disabled condition. Alright, let us go to the next slide. Remember, these configuration properties are mostly optional and mostly refer to special cases when you need to reconfigure the JUnit runtime in some special way. In the labs preceding this appendix, we added the JUnit-platform.properties file to our tests and added a few configuration properties. Now is a good time to add the others and to experiment with how the JUnit runtime changes its behavior. And you can do so on your own. I highly urge you to do so. You can also implement your own custom configuration properties if you're extending the JUnit runtime. I leave it as an exercise for you to implement a custom extension, make sure it has a need for custom configuration properties, specify those custom configuration properties in the JUnit-platform.properties file, log how the extension runs and what values it uses for these custom configuration properties. So, thank you for your attention. This concludes our appendix, and good luck.